Welcome to cell potential, electrical work, and free energy. So let's talk about free energy and redox reactions. For any electrochemical process, we know that the standard cell potential for the complete cell is equal to the standard reduction potential for our reduction process minus the standard reduction potential for our oxidation process. And a positive E0 there for the cell indicates a spontaneous process. A negative cell potential indicates a non-spontaneous process. So a spontaneous process is a process that will go. A non-spontaneous process is a process that won't go. But not only that, the reverse reaction then is spontaneous. So that equation is used to understand the activity series of metals. So let's look at the reaction of nickel with silver ion. So we've got nickel solid plus 2 silver ions react to give us nickel 2 plus and 2 silver atoms. And the cell potential then is the standard reduction potential of our silver half reaction minus the standard reduction potential of our nickel half reaction. And this is plus 0.80 volts minus a negative 0.28 volts, which gives us a positive 1.08 volts. And because we've got a positive value there for our cell potential, then our reaction is spontaneous. So we will in fact have nickel 2 plus go to nickel 0 and silver plus go to silver 0. We will have the nickel 0 go to nickel 2 plus and the silver go to silver 0. So we can show that the Gibbs energy, or the change in Gibbs energy, delta G, is equal to minus NFE, right? Delta G there is the change in free energy, Gibbs free energy. N is the number of moles of electrons that is transferred, that's this N here. F is the Faraday's constant, and E is the electromotive force of the cell. This is the cell potential. So we define a Faraday as 96,485 coulombs per mole, and that then is equal to 96,485 joules per volt per mole. And because N and F are positive, then if delta G is negative, if it's less than 0, then we know that the cell potential is greater than 0, and the reaction will be spontaneous. So again, we see that if Gibbs free energy is negative, reaction is spontaneous, and we now have a way of linking that to cell potential. If cell potential is positive, then Gibbs energy is negative, and we know if Gibbs energy is negative, then reaction is spontaneous. So if cell potential is positive, then the reaction is spontaneous. If cell potential is negative, that means that Gibbs free energy change will be positive, and that's a non-spontaneous reaction. So when our reactants and products are in their standard states, then we can take this reaction, or this equation rather, and turn it into this one, where we've added the condition that the Gibbs free energy is now at standard. This is the standard Gibbs free energy change, and we have to use then E0, so we have to have our cell at standard conditions. It's really just a special case of the top reaction there. So a voltaic cell is functional until the cell potential is 0, at which point equilibrium has been reached, and because our voltaic cell is a battery, essentially, our battery is dead, our cell is dead, no further reaction occurs, at least no net reaction occurs. The point at which our cell potential is 0 is determined by the concentrations of our species involved in our redox reaction. If we change one of the concentrations, then that point will change. So that was cell potential, electrical work, and free energy.